Hi everyone. So today we will be working on our next topic for chapter 3, and that is going to be about arithmetic and geometric sequences. So for this topic, we will be writing terms of an arithmetic sequence and also use the formula to find for the general term of an arithmetic sequence. Same thing goes for our geometric sequence. We're going to write the terms and also use the formula to find any term from a geometric sequence. So for starters, let's have some definitions. So when we talk about a sequence, it is a list of numbers that are related to each other given by a rule. Okay? The numbers in the sequence are called the terms. So each number that you will see in that sequence, in that list, is what we call as the terms. So let's have the easiest example, and I think this is one thing that you have already encountered before when we were in chapter 1. The Fibonacci sequence, this is a special sequence because what happens is to find the next term, you have to take the sum of the two previous successive terms. So if you would remember, our Fibonacci sequence would be 1, 1, 2, 3, 5, 8, and so on and so forth. And for you to be able to get the next term, you need to add the previous. So as you can see here, 1 plus 1, that's the 2. 2 plus 1, that's the 3, the next term. 3 and 2 together would be 5. So this is a sequence. How do we know it's a sequence? It's not just a list of numbers. You will see that there is a pattern, there is a rule. And what was that rule? We add the two previous terms to get the next one. So to get you familiar with some notations, you will notice that when we are talking about the terms, so again, terms are each of these numbers in the list. So you will notice that you have A sub 1, meaning this is the first term, second term, third term, and so on and so forth. So we represent a term with the variable A and then a number to indicate what number, which is the order of it in the list. So we have, for this particular lesson, we will be focusing on two important kind of sequences. First one is what we call as the arithmetic sequence. So when we talk about arithmetic sequence, the pattern, so all you need to remember here is that the pattern or the rule is you are adding or subtracting the same number, whether it's a positive number or a negative number. So that common number that we are adding or subtracting is what we call as the common difference. Now, for us to be able to get the common difference, it's always the new term minus, so let's say new term, let's say 8 sub 4, the fourth term, minus the third term. It's always the current minus the previous term. That's how you will be finding the common difference. So let's have these examples. So we can say that this is an arithmetic sequence. Why? If you take a look at the pattern, 142, 146, 150, 154, you will notice that it is increasing by 4, all right? So the fact that the pattern you are seeing is always plus 4, plus 4. Oops, sorry, I don't know what happened there. It's always plus 4, plus 4. So we know that this is an arithmetic sequence. So how are we going to find a common difference? So you can select any two consecutive terms. So let's say we have this one, 158 minus, okay, the previous is this one, 154, and the answer is positive 4. So the common difference, even though it says difference, I know it's usually associated with subtraction, okay? So the common difference is going to be positive 4, okay? Now let's take a look here. We have negative 5, negative 2, positive 1, 4, and 7, okay? What pattern are you seeing? So you can check any consecutive terms here. So let's say 4, let's have 4 and 1. So that will be 4 minus 1, which is 3. And you can also check, does it also work with 7 and 4? 7 minus 4 is also 3. So the common difference is 3. In this case, looking at our term, we have 8, 3, negative 2, negative 7, negative 12. So if you're going to take a look at the pattern, for 8 to become 3, you had to subtract by 5. All right? Now, to check, is it always subtraction by 5? So you can always find the difference by, you can always find the common difference by subtracting the common term, the first term, sorry, not the first term, the current term and the previous. So you can have like -2 minus 3, okay? Now, according to our rules, it has to be change the sign and then add. So it is indeed -5, okay? So when you have a negative number as the common difference, then you know that the pattern is subtraction, all right? So again, highlighting this, when we talk about arithmetic sequence, the pattern is you are adding or subtracting the same value, all right? So let's have an example here wherein we are going to be writing the terms. So this problem says write the first six terms of an arithmetic sequence with the first term, okay, 6 and a common difference of 4, okay? So we needed how many terms? We need the first 6 terms. So we have a sub 1, sub 2, 3, 4, 5, and the 6th term, okay? So according to the problem, do we know what is the first term? We always need to know the first term. So that would be 6. And what do we make use of the common difference? This is a positive 4 common difference. So we need to add 4 every time to get the next term. So 6 plus 4, that's going to be a 10. Plus 4, 14. Plus 4, 18. Plus 4, 22. Plus 4, 26. So these are the first 6 terms of this arithmetic sequence. All right, next. Now, if we are going to take a look, okay, in general, any term, okay, let's say we have a specific, we are talking about just a specific number. Any term that we have, so we always represent it as a sub 1, okay? And then the second term pretty much is always, we add the first term with the common difference. Now, to get the third term, you will notice that we are going to add 2 of the common difference. So that's why you will notice that every time we move to the next term, our common difference gets to be added, okay? And because of this pattern that we are seeing when we talk about arithmetic sequence, we have a generalized formula in such a way that any term that we have in the sequence, we can find easily. And that is by using this formula. Okay? So any term, whether you're looking for the 100th term, well, you don't need to list down all 100 numbers to get from the sequence, right? So in general, okay, when you are looking for any term, all you need to do is have the first term, add it to the product of the common difference, and then n minus 1. So all you need to, so if you will notice the n, so we are third, okay, third term, we are multiplying d by 2. Why? Because we have 2 of them in the common difference. And that pattern will always be represented by n minus 1. Where do you find this n? It is this one, okay? So let me give you a specific example for this. Find the 8th term of the arithmetic sequence whose first term is 4, okay? And his common difference is -7. So we're looking for the 8th term, okay? Pretty much this is an easy list down, all 8 terms, right? But if we want to use the formula, okay? Remember the formula is a sub n. Oops, sorry, my bad. Let's just ignore this part, okay? A sub n is equal to the first term plus n minus 1 times the common difference. So what term are we looking for? We're looking for the 8th. So we will replace our n by 8. So this is now a sub 8 is equal to, do we have our first term? Yes, that's the 4. Okay, plus n minus 1. Where is this n? This is that n. So this is that number. So we will have an 8 minus 1, and then our common difference is -7. All right? And if you work out this value, you will have 4 plus 8 minus 1 is 7. And then you have multiply by -7. Now remember, by PEMDAS, we do the multiplication first. So this is going to be +4 plus 7 times -7 is -49. Now, if you are adding a positive and a negative, technically you're subtracting. So from here, you know that the eighth term will be -45. Okay? So this is how we can find any term in an arithmetic sequence. The formula is this one that we will need to follow. All right.